Hey guys, my name is Jason with Mount Baker Mining and Metals, and I know you guys have been excited about seeing more mining and drilling videos from up at our claim. So I've got some footage here of me drilling out a face round, and then at the end of the video I reached way back into the archives and grabbed some footage of us mining about 10 years ago. And the video quality isn't great, but it really shows how a small scale mining operation works and operates, and all the steps from drilling and blasting, slushing and mucking. So hope you guys enjoy the video. Now we got to get all this air hose and one of those oilers out there by our face, that snow patch there, and get her hooked up to the little compressor here, and then we can go drilling. Get her hooked up to the water, get some steel out there, and one of these jack legs. And we'll go drill some holes. Okay, we're all set up at the face. The green is water, the yellow is air. I got my machine hooked up. Now let's get her started. The drill I'm using is a Gardner Denver FL83 rock drill, and it's powered with that air compressor we saw earlier. It's a 185 CFM compressor, and the green line connecting to the drill is the water line. That supplies water through the drill, and it gets pushed by the water needle down through the drill steel, which is hollow, into the bottom of the hole. And the water keeps the dust down and runs the cuttings out of the hole. The leg is pneumatically powered as well, and I have controls up on the drill for both the speed of the drill and the pressure on the leg, both of which can be adjusted. And the machine weighs about 120 pounds. Most of the work is done by the leg, but moving the drill around and pulling it out of the holes can be quite the job. The end of the steel has a button bit on it. What we use are button bits, but it has several buttons of a very hard abrasion resistant material on the end, and that's what does the actual drilling of the hole. And the machine will hit the steel into the hole and turn the steel a quarter turn, and so that's how the machine actually drills the holes. I'm working right now on the burn cut, so we'll take a closer look at that here once I get that drilled out, and I'll explain why I've drilled the holes in the locations I have. All right, I stopped for a little lunch and wanted to give you guys a little tour of what's going on here. So I've pretty much finished with my cut here. And on some of my older videos, I'm getting the right spot here. Some of my previous videos, you guys really wanted to know more about drilling patterns and drilling and blasting and stuff. So this is the way I was taught. There's a couple different ways of doing it. But I got my 5 holes here. They roughly look like a 5 on a dice. And the center hole here is the 0 hole, so that doesn't get loaded with any explosives or anything. Oh, flies. And so that'll be our 0 hole. And then you load 1, 2, 3, 4. The caps are numbered,
in sequence. And so you want them to go off in sequence. And the whole point of this burn cut here is the 0 hole, you got to have somewhere for the first shot to blast to. So this is going to be our number 1 hole, and I drilled it pretty close to the 0 hole. So when that one blasts, the shock and the gases have somewhere to break to. And then this will be number 2 probably, number 3, and number 4. And then by the time all 4 of those go, you'll have a big hole right there. And so for the next couple, then I can come back and I'll probably put one up here and one down over here somewhere. I'll do 4 and make kind of a box there, blast the corners in, and then I can really start opening this thing up. And so I'll get those done. And the other thing I'm going to do, it's hard to tell on the camera, but where the burn cut is back about 2 feet from this edge. And so I think I'm going to keep those at 4 foot depth. And out here I'll do 6. So when it all blasts, the face will be flat in the back. But because if I do them all at 6, I'm going to have a little whoop-de-doo in the back or in the face, and I don't want that. I want when it's shot and done, I want a nice flat back, a flat face about 4 feet from the collar of the burn cut there, and then a flat floor, a couple of ribs. Hopefully the quartz stays on this side, and then we can kind of see what we got. But anyway, there's like a little bit of a lesson on drill pattern and the cut here. Like I said, I'll do 4 more, and then I'll get them really opened up, and I'll show you guys when I'm done here. Another thing I'll mention here is you may have seen in a couple of shots I had this PVC in there. And you want to have your burn cut especially kind of all be parallel with each other. I mean, all the holes should be, but you can use the PVC as kind of a guide. You have a 3-dimensional problem here. You want the holes to be more or less parallel, because that first hole is important to be 2 or 3 inches at the collar and at the bottom of the hole to be 2 or 3 inches off the bottom of your 0 hole. Because if it wings off out this way, you're too far away from your 0 hole to blast into it. So the burn cut especially, the holes all need to be about parallel, about running all the same way. And the goal is the collar of the holes, right where it goes into the rock, and the back of the holes should be about the same distance away from each other. So you can blast out that middle section and then have somewhere for all the rock to go. And when I do my burn cut, or my cut there, I keep the leg in the same spot. So I haven't moved the leg for any of those holes, and I can get them all pretty much where I want them. And now that all 5 of those are in there, then I can start moving the leg. You know, I'll have to move the leg 6 or 8 inches, 10 inches over here to get these holes over on this side, and then back over here and to get the face. Because there again, you want all the holes to be more or less parallel with each other. And so I got to move the leg, because if I keep it all in one spot, they're going to start winging out sideways and up and down and around. So I gotta move around and make sure it all stays parallel with each other. All right, we got our round drilled out. And I started at noon, and it's about 4 o'clock now, so it took me 4 hours. But I am dog tired. That is hard work. Every year, that first round, man, it always kills you. But let's go look at our face behind me here. Here's our face, and right here's our burn. That's those 5. That looks like a 5 and a dice. There's a 0, 1, 2, 3, and probably 4. And then I got a hole down here, there. Those will be the next 2. Then I got one up here. That'll really open up that hole there. I've got one up here, 2 for the back here. Oh no, let's see, where am I at? Oh, those 2, and then this one and that one up there are the back. So I'm going to open up this whole face here. Then I got this one and one down here, and that'll have this whole thing opened up. I got one over here, one down here, a couple below, and then 1, 2, 3 lifters. And the 3 lifters are the bottom 3. Those will go last, and that kind of blasts all the muck up and out of the hole. But yeah, we'll load the burn, and then I'll probably start shooting 2 or 3 of these together.
This is some footage from over 10 years ago when we were mining underground, and we are working in the drift, drilling out a drift round. And unlike on the surface, this round is only going to be about 4 feet wide and 6 feet tall. And this is a slushing operation, so we don't need the drift very wide. Our vein is only about 2 to 4 feet wide. And so once we drill and blast, then we slush the material down the drift to a drop point. And once the ore reaches the drop point, it falls down to the main level where it can be accessed by the diesel-powered mucker. Here's a shot of the slusher. It's an air-powered double-barreled winch. We anchor a block to the back where the face is, and the slusher operator can control this bucket, so he can pull it towards him to the drop point and pull it back towards the face, and it just pulls the ore, the broken ore and rock, down to the drop point.
Take a look at it, Jason. We don't have to come all the way out with it, you know. I think it just come back there past the curtain a little ways, you know.
Okay.
And just let it fill up here, you know.
Make a pile, huh?
Yeah.
Okay.
Let's take a look here.
Put it over your head. Okay, Kurt. Yep. Come back and look.
That was not that great, is it, Jason?
No, it's split right here in 2 little ones. And
There's all one in the back there, though, eh?
yeah, this here.
Yeah.
Yeah. It's a good sulfide.
That's good stuff there. But
Yeah.
That's not enough of it. Anyway, we'll
Do another round. Hopefully it doesn't pinch off, you know.
I
said it might go back and pinch.
Yeah, that's kind of what it looks like right there. See that?
Here,
Yeah.
yeah,
Anyway, we'll go another round, I guess.
yeah. See what it looks like. I thought the vein was more over here in the last round.
It was over there in the last round, right there.
Was it?
Yeah.
Or it pinched off here or something.
It was right over here. See that?
Yeah. Huh. Yeah, it really did cut in, didn't it?
Okay. bring the water hose back and I'll do the pinhole back here.
Here the vein isn't very mineralized, so we have not done any work on it. But we chose to see an area that is mineralized, and that's where we're working right now.
Here comes the miner.
Oh, where? Where the hell are you? I'm learning. There you go. How far up are you? Oh, about 25 feet. That's wet, yeah.
Now they're working the vein right here, up to this little raise. Now we're looking straight up on one of these raises, and this up here is about 4 feet wide. That's the face they're working. They're working all the way across the face up from the drift. We've got these little pillars in here that they're working off of, and then the muck comes down through the pillars, and then down here on the bottom of the drift so the mucker can get to it. Tell me where you started, what the columns are for, where they're, how often they're spaced, where you're working right now, what's going on?
Well, we got 3 pillars here. And when we started, it was just a drift, an 8x8 drift. And as you can see, the vein's real wide here. It's about 3.5, 4 feet average across this 40 feet that we're soaking up on. And we left these pillars about every 6 or 8 feet because we were worried that if we opened up the whole scope 40 feet long and you had the big overhang here from the drift, that the wall would all start caving in. So we left these pillars, and it's really done quite nicely. You can see if you look up there, the walls are smooth and straight up both sides, so it's a good thing we left it.
What's your grade running here?
That's a question for Lane. I think the muck's running about 3/4 of an ounce.
Oh, really?
Yeah. But you can see right there on that pillar, you can see
Point to it.
different kinds of quartz there.
Take that stick and point to it.
You can see the kind of orange rusty quartz shown out there. And Lane just sampled that separately, and that assayed 0.004. Point to it again. Right to there.
All right.
From here to there. And that's not running anything.
All right.
And then you can see from here all the way to the wall is that nice white quartz with sulfides in it. And that's the stuff that's running good. That's probably running over an ounce.
I see.
Why did you put an anchor right there?
A bolt?
Yeah. You get cracked or something?
Well, yeah, the ground, we were worried when we opened this up that the wall over here did bad. And so we put a bolt in here, and there's one down there farther. But actually, when we got up there, these pillars were enough. Once we left the pillars here, the wall stayed real good. See how smooth and straight that wall is up there?
Yeah, perfect.
Yeah, so the wall stayed really nice.
How long is that anchor?
That one there's 4 feet. We put one in down there at 6.
Now you drill the hole, you put it in there, and then you have to beat on it to get it to mushroom, or how do you get it to mushroom?
No, you just put the drill to it with the special bolt driver. And it drives that bolt right in there. And we did a pull test yesterday for MSHA to see how much weight it can hold.
Yeah.
And one of those bolts held 25 tons.
Tons?
Tons.
Yeah, that's enough.
So. Here's the small mucker that we use, and this is a 1-yard bucket on a very small underground mucker. Our drift is 8x8 for the main drift here. And that machine is a diesel-powered machine which can be run underground. It does not produce any carbon monoxide. Once the mucker grabs a bucket of ore, it can back its way out of the drift, outside to where we pile the ore for loading into trucks. And the operator sits sideways so that they can see both forward and backward. This mining operation, we produce between 300 and 500 tons per season. Our grade averaged around 1/2 ounce to 3/4 ounce of gold per ton, and we were shipping all the ore off the mountain down to a processing plant on the other side of the state. So I hope you guys enjoyed the video. It's kind of a throwback for me from the days I worked underground, and hopefully in the future I can get the mine up and going again and we can start getting some more gold out. So thanks again for watching. If you guys have any questions or comments, you can find our contact information in the description below. So thanks again, and we'll see you on the next one.